In this lesson, we're going to be graphing quadratic functions by graphing the equation y equals ax squared plus c. The c added to the equation explains the vertical translation of the graph compared to the parent graph of y equals ax squared. It's going to tell us if the graph is going up or down compared to our original parent graph that's vertex is at the origin, 0, 0. In these next examples, we're going to graph the functions and then compare it to the parent graph of y equals a squared. In this set of notes, I don't give you an extra graph to graph ax squared, so we're going to do both of them on this first graph example. Remember, for ax squared, it starts at the origin. I'm going to go ahead and make a t-chart for ax squared, and then we're going to graph that one first, then graph the y equals x squared plus 3. So as I've said in the past, I love to use -2, -1, 0, 1, 2, and I'm plugging it into the parent graph equation first. So -2 squared is 4, and then the parent graph actually has 1 as a. Okay, so it's going to be 4. -1 squared is 1 times 1 is 1. And then usually when we have 0, it's at 0. 1 squared is 1 times 1 is 1, and they swoop up. So our parent graph is going to look like this. All right, so that's our parent graph. Now we're going to switch gears, and we're finally going to get to the actual equation of y equals x squared plus 3. So we still are doing our xy charts, and we're using -2, -1, 0, 1, 2, and we're going to plug them in. -2 squared is 4, 4 plus 3 is 7, -1 squared is 1, 1 plus 3 is 4, 0 squared is 0 plus 3 is 3, 1 squared is 1 plus 3 is 4, and you can see they still do swoop up. Now, the one difference we're noticing with our points is that we have 0, 3 as a coordinate instead of 0, 0. And that's that vertical translation we're talking about when we add a c into the equation. So our points are going to be at -2, 7. Then we have -1, 4, 0, 3, and then we're going to just mirror them or reflect them over. All right, so we've graphed both of them, and now you can see a clear comparison. The one thing that's different, because the graphs are the same width, is that it translated 3 units up compared to the parent graph. And as you guys might already realize, this c is going to be like our y-intercept. It's going to tell you if we're going to go up or down compared to its parent graph. For this example, we are just going to graph y equals x squared minus 2 because we already have the parent graph on the other graph that we just graphed. So we are going to just make our t-chart of -2, -1, 0, 1, 2, and plug it in. -2 squared is 4. 4 minus 2 is 2. -1 squared is 1 minus 2 is -1. 0 squared is 0 minus 2 is -2. 1 squared is 1 minus 2 is -1. And then you guys can definitely see that it's swooping again. So we're going to graph this graph, -2, 2. I'm just going to mirror it automatically. And then I know I don't have the clear point at 0, -2, but it's right there. And then we graph. Okay. So again, our slope, if that's what you want to call it, is the same as our parent graph. We just have a 1 in for a, which is what the parent graph has. The only comparison is with this graph is that it translated, and remember, translated means that it slides. This is just the better mathematical vocabulary to use. Translated 2 units down. So make sure you guys write that down. And they do have the same slope, so that's our only difference. Now we're going to use another example. However, you'll notice that now there is a number in front of x squared that is not 1. So we're going to see how that affects our comparison between this graph and the parent graph. We're still going to do our xy chart of -2, -1, 0, 1, 2, and we're going to see what happens. So -2 squared is 4. 4 times 4 is 16, plus 1 is 17. And again, if I move fast, you guys can go ahead and pause this video, do your mental math on your own, and then check your work with my work on the video. -1 squared is 1 times 4 is 4, plus 1 is 5. 0 squared is 0 times 4 is still 0, but you still add that 1 at the end, and then our items swoop up again. Now, we're probably not going to be able to get to -217, but as long as you can graph 3 points, I'm okay with it. So I'm going to go to -1, 5, 0, 1, and then I'm going to reflect to the other side of the y-axis. Now we have our graphs. Because we have a different slope, we are going to go ahead and have a couple comparisons in this graph. So our first comparison is the fact that this graph translated up 1 unit. This is what we've been working on for this whole lesson. It is also more narrow, or we've talked about skinnier, than the parent graph. All right, so those are going to be our comparisons. I'm going to widen this out so you guys can see it. So we have that as those are our two comparisons to the parent graph. We are going to go ahead and do another example just like this. We have a -1/2 this time as our A coefficient. So it's going to work on our mental math with fractions. If you need to pause the video, try it yourself, go for it. I'm going to go through and do my mental math out loud. So -2 squared is 4. 4 times a -1/2 is the same as 4 divided by a -2, which is a -2. And -2 plus 4 is 2. -1 squared is 1 times a -1/2 is -1/2. And -1/2 plus 4 is the same as 4 minus 1/2, which is 3.5. 0 squared is 0 times -1/2 is still 0, but then you add 4, and we're going to swoop around all of our numbers so we have these points. So when I graph this, I'm going to go to -2, 2. I'm going to go to -1, 3.5. I'm going to go to 0, 4, and then come back around. Now, you guys should see and have known that this quadratic was going to open down because it was negative. Okay, and that's definitely something we're going to talk about right now when we're going to compare. So the first thing we're going to write is the graph is reflected, okay, which means it opens down. And then it translated 4 units up. And then with our -1/2, we do know the negative made it open down, but it also is wider than the parent graph. And if you need to really double check that, you guys can look at that first graph we did that has the parent graph listed alongside the example. All right, so let me go ahead and fix that for you guys, and then you can see it. All right, there you go. Now, what I want you guys to do is try the next example on your own and see how you do. We'll talk about that in class. In the next couple examples, we are given a graph, and it does not ask for us to graph the item. They're just asking us to see the translation and describe it between two graphs. Now, as you guys see, the graph of x squared minus 5 is shifted to the graph of x squared plus 2. So we are starting here. This is going to be our first graph, and this is going to be our second graph. So we start at x squared minus 5, and then we go to x squared plus 2. Now, if you were to think of a t-chart, we would start at -5, okay, and then we go up to 2. Think of our y-intercepts. So describe the translation. If we were to describe this translation, the graph translates 7 units up. We started at -5, and then we were able to move up to +2. So that'd be a 1, 2, 3, 4, 5, 6, 7 unit translation, and we have to explain the direction as well. And that's it. In this example, we have the same situation. We have the graph of 2x squared plus 1, and it's shifted to the graph of 2x squared minus 1. So this is our first graph, and then we move to this graph. So they do have the same slope, and we don't even need to worry about that because we're worried about describing the translation. The translation is our C value, whatever is added or subtracted. So we started at plus 1, and then we moved to minus 1. Okay, so to describe that translation, the graph translated 2 units down. And that's all you have to write. The word problem we have for this lesson is actually bringing us back to our factoring days. So what we have here is the function of ft equals negative 16t squared plus s to the 0 gives the approximate height of a falling object however many seconds after it's dropped from its initial height. So we're talking now about an egg. An egg is dropped from a height of 64 feet. So we're wondering, when does the egg hit the ground? So our initial height is 64, which is what we're going to plug in for s to 0 because it says that's what our initial height is. So I'm going to rewrite our function by plugging in that amount, 64. Now, what we're going to have to do is we're finding out how many seconds it takes for it to touch the ground. Because of that, our ground is going to be 0. So our height is at 0. And now we have our equation that we're going to solve. If you guys remember, this should look like the difference of squares. However, I do need to make sure that our t squared, this is a positive number. So by doing that, I'm going to factor out a negative 1 because it's negative right now. By factoring it out, I'm left with a positive 16t squared minus 64. Now you can really see that it is a difference of squares. I'm going to do my equal sign and have this all equal to negative 1 times 4t minus 8 and then 4t plus 8. I found those square roots of those problems. Now, because we have it equal to 0, we have to solve for 8. So I have, or solve for t, I'm sorry. We have 4t minus 8 equals 0, and then 4t plus 8 equals 0. All right? When we add 8 to the other side, we're left with 4t equals a positive 8, t equals 2, and this is going to be the opposite of t equals negative 2. Now let's look at and see what our problem is asking. It says, when does the egg hit the ground when we drop it from a height of 64 feet? Whenever we're dealing with time, we are always talking about the positive. It takes 2 seconds for that egg to hit the ground, not negative 2, but positive 2. I want you guys to try this next example. It's the same equation, but now the egg is dropped from 100 feet. So you guys will have to do the same process that we did prior, and we'll talk about this in class. Please make sure you star any examples that you had trouble with, and we'll talk about them the next time we talk about this lesson.